Welcome back to more fun with Algebra 2 final exam review. Um, got some easy questions going on here now, so this will be a little easier section. Starting here at 57, this is asking us to rewrite this expression in rational exponent notation, meaning take it from radical form and put it with exponents. Easy stuff. So this is going to be 27 to the 5 over 2. Remember, exponent on top, index on the bottom. 58 would be negative 15. It doesn't have an exponent, so we give it a 1. Has an index of a 7. Just remember, because it's negative, we need to leave it in parentheses. And for 59, we have 24, exponent of a 3, but it doesn't show me an index, but that means it's an automatic square root, so it's 24 to the 3 over 2. Moving on to 60. Now they want us to go backwards, take it from exponent into radical notation. So again, 37 is my radicand. So it has an exponent of a 5 and an index of a 4. 185 to the 1/2, again, 185 is my radicand. 1 is my exponent, 2 is my index. Technically speaking, neither one of those exponent or indexes is necessary, but we're going to put them in there for right now anyhow. And then 62, 121 to the 5th power with an index of a 3. Now, most definitely, these next two questions, you really need to know how to do these. We spent much time going over these. So these are using your charts, okay? Remember, negative exponents means this thing is going to automatically flip into 1 over 32 to the 3/5. If you remember what we did in class, we took the 32 and we looked on the 5 chart. Well, 32 happens to be 2 to the 5th power. Still has a 1 up here, and we still have a 3/5 on the outside. The 5s will cancel, leaves us 1 over 2 to the 3rd, which would be 1 over 8 as a final answer. For 64, 125 on the cube list happens to be 5 to the 3rd to the 2/3. Those 3's will cancel, which leaves us 5 squared, which happens to be 25. Okay, those should be the easy questions on the test, y'all. For number 65, you have the cube root being cubed, which means those undo each other and leave us a final answer of negative 64. There's really no work to be done there. And then for 66, I would rewrite this in exponent notation and make it 16 to the 5/4, because then I could look at my chart and say, well, 16 is 2 to the 4th power to the 5/4. The 4's will cancel and leave me with 2 to the 5th, otherwise known as 32. Then we move into solving radical equations. Now, these two, again, when you see this in the directions rounded to 2 decimal places, this means you're going to need a calculator, y'all. Again, I don't know that we're going to necessarily see a ton of these, if any, on the exam, but you need to be ready just in case. The only way to get rid of a 7th power is to do the 7th root of a 7th power and the 7th root of a negative 215. And again, because I know we're not all working with the same calculators, this would also be the equivalent of negative 215 to the 1/7 power. Most of our calculators can handle doing that, and that's going to leave us an answer of x equals negative 2.15. For number 68, we need to add 26 to both sides, so we get 5x to the 4th equals 40. Divide it by 5. Get rid of that. We have x to the 4th equals 40. So now the easiest thing to do would be to raise both sides to the 1/4 power, That would cancel and leave us with x equals 40 to the 1/4, which we would put in our calculator. I'm sorry, not 40 to the 1/4. Sorry, y'all. That would be 8. And 8 to the 1/4 would actually give me plus or minus 1.68. And again, because we're not all working on the same calculators, we may or may not see those questions. The ones you will see will most likely be the things you can use your perfect square, perfect cube lists to help you out with. More along the lines of questions, I would say like 70, 72, these types of questions. We're going to do all 4 of these just to be on the safe side. So for number 69, they want to simplify. Remember, simplify means you may end up with square roots, cube roots, etc. in your final answer. So we need to take the number 54 and see what number on the cube list, because it's a cube, goes into 54. Well, that would be 27 times 2. So over each one of these, we're going to put a cube root. The first one should be a perfect cube, which means that's going to be 3 cube root of 2. That would be our final answer. Again, the idea that they say no decimals means if you try to put that in a calculator and you get a decimal answer, there should be something else that you're doing with that problem. Same thing here with 200. I need a perfect cube that's going to go into 200. Well, so we know that 200 is 100 times 2, but 100 is a square root, not a cube root. But 8 goes into 200. 8 times 25 would be the numbers we're looking for. So if I take the cube root of 8 and the cube root of 25, the only one that has a cube root is 8. So my answer would be 2, because that's the cube root of 8, cube root of 25. Okay. When you have problems along these lines, remember a 1/4 power, this actually would be the equivalent of saying I have the 4th root of 5 times the 4th root of 3. Well, if these two had the same indexes but different radicands and they were being multiplied, we would say that this would be the 4th root of 15. Well, how would I rewrite that in fraction form? Would be 15 to the 1/4. Okay, can't be simplified from there, so you just leave it alone. When you have two radicands being divided with the same index, the first thing to check for is to see, do these numbers divide? Well, 80 divides by 5. That leaves me the 4th root of 16. Well, if I check the 4 list, or if I rewrite this as 16 to the 1/4 power, 16 is 2 to the 4th. If I raise that to the 1/4, the 4's will cancel and leave me with 2 to the 1st, which is just 2. Okay, when we're adding or subtracting, we have to make sure of 2 things. We need to make sure that their indexes match, and we need to make sure that their radicands match. In this case, they both do, so the only thing missing is there's no number in front of this radical, which means we're going to just put a 1 to hold spot. And all we're going to do is add up our leading coefficients here. This would end up being 8 4th root of 10. And the nice thing about a question like 74 is you have 2 options. You could either multiply 125 times 8 and see if it is a perfect cube. Okay? Or you could say, well, 125 is on the cube list, it's just 5, and 8 is on the cube list, it's just 2. 5 times 2 is 10. There's your answer. It's probably the easiest way to go about it. Okay. You may, the next part of this, we get into the function notation problems, okay, with our rational exponents, okay. You may see these, you never know. Again, remember, everything in these study guides is fair game. The ones we listed off in the very first video are the most likely of the bunch, okay? And I've tried to highlight those as I've gone through in these videos, so please make sure, because the question numbers have gotten shuffled a little bit, I'm using a different document here. question numbers are slightly off, so please go back and watch these videos and look for the ones that we've highlighted, the ones that we've worked all the way out. Make sure you're comfortable with those. So in here, if we're being asked to add this equation to this equation, the exponents aren't going to change any. All we're doing is adding whole numbers. So negative 3 plus 12 is going to give us 9x to the 2/5, sorry. Looking at the wrong number there. And negative 7 plus 8 is plus 1. There's my answer. If I'm being asked to subtract f of x minus g of x, it's the same idea. Again, just watch your signs. If I say negative 3 minus 12, I get a negative 15x to the 2/5. Again, your variables and your exponents will not change. But if I do negative 7 minus 8, I would end up with a negative 15. And that would be our final answer there. Sorry for the sniffles, y'all. Now, I will say this question right here, the f of x times g of x, I think is one you are likely to see show up. So for that one, they're asking you to do negative 12x to the 1/3 times 4x to the 1/3. But this is not anything unlike questions we've seen before. We need to multiply the numbers out front. Well, negative 12 times 4 is negative 48, and then we need to add the exponents, but conveniently, oh, they already have common denominators, so we get x to the 2/3. If we're being asked to divide these, that would be negative 12x to the 1/3 divided by 4x to the 1/3. Well, that's quite convenient because those two cancel out. Well, negative 12 divided by 4 is negative 3, and there's your final answer. Okay. The composition of functions is our next part of this. You'll be given the three functions and asked to either perform a composition with a whole number, or you'll be asked to perform a composition with a variable. Either one is just as likely. So, if we're asked to do f of g of 2, remember the first thing you do is plug 2 into the g equation. Well, that would be 2 squared minus 7, or 4 minus 7, or negative 3. And then we take the negative 3 because the equation on the outside is the f equation. We're going to take the negative 3 and plug it into the f equation. Well, that would be 1/2 times negative 3 plus 3. Okay, so we have some fractions in here, but not horrible ones. Half of 3, if you want to work with decimals you could, is negative 1.5 plus 3 is positive 1.5, or positive 3/2. Either one would be a perfectly acceptable answer. Definitely I'm going to put a star by question number 80 because this is one that I think you're likely to see. They want you to plug this equation, the f equation, into this spot in the g equation. So we're going to take the g equation, the g of x equation, which is x squared minus 7, and we are going to take this little x out and plug in everything we highlighted in purple. So that is going to mean we're going to have parentheses 1/2 x plus 3 squared minus 7. Okay, this would be a case where we would have to FOIL this. So we would have to FOIL 1/2 x minus 3 times 1/2 x minus 3 minus 7. When FOILed all together, we should come up to 1/4 x squared plus 3x. We would get plus 9, and then I'm going to bring down this minus 7, so we'd get a final answer of 1/4 x squared plus 3x plus 2. And the nice thing is if you happen to get your h of f of x, Well, that's not the worst thing in the world. That means you're going to plug the f equation. Again, we're working with the purple one. We're plugging that into that little spot in the h equation. Not the worst thing in the world. So the h equation stays as is. 2, but instead of the x, we're going to plug in 1/2 x plus 3. The rest of the h equation is minus 3 over 3, and do some simplification. Distribute. Well, half of 2 is 1x. 2 times 3 is plus 6, minus 3 over 3, and combine your like terms on the top, so we get 1x plus 3 over 3, and that would be our final answer. Okay. So moving into the next part of this, finding an inverse equation. I think you are likely to see one of these at least, and it's probably going to be an x squared equation of some kind, so I think 82, whoops, it's meant to highlight that one. I think 82 is a perfectly good example. Remember, when you have to do this, the first step is to switch x and y. Resolve that equation for y, minus 3 on both sides. So you have x minus 3 equals 4y squared. Divide both sides by 4. So that'll give you x minus 3 over 4 equals y squared. And then to finish it off, you're going to take the square root on both sides to get rid of the y squared, and that would be your final answer. For 81, again, you're switching x and y. So if you would have x equals 3 minus 2y, we would minus 3 on both sides. X minus 3 equals negative 2y. Divide by the negative 2, cancel that out, and that would be your inverse equation. 84, we're going to give you the solution for this. The solution for this one would turn into, oh, my apologies, slippery hand, would turn into y equals negative 2x minus 10. And for 85, we would get the square root of 3/2 x minus 6. Okay? Again, I think the two you probably want to concern yourself with are 82 and 83. Approaching the end here. While we did go through verifying inverses, I think it is highly unlikely that you will see those questions. Again, remember, to verify an inverse, you plug one equation into the other and verify that it comes down to just give you the x, that basically everything cancels away. So we'll show just one example of this with these first two equations. If I were to take the f equation and plug it into the g equation, so if I were to do that, this would turn into 1/2 parentheses 2x plus 1 minus 1/2. That's the g equation with the f equation replacing the x. If we distribute, we would end up, well, half of 2 is 1x, half of 1 is 1/2, minus 1/2. Those cancel out and just leaves me with x. It would be the same way if you plugged the g equation into the f equation. But again, wouldn't worry so much about those. I do think you will want to make sure that you know how to graph your square root function, since we just finished this chapter. It's most recent for us. The original table for a square root function is 0, 0, 1, 1, 4, 2, and 9, 3. But this right here tells us that we need to shift all of the x numbers up by 1 And this right here tells me that I need to shift all of my y numbers up by 2. Remember, whatever's in the radicand, you do the opposite. So if we do that and we draw our new table, well, that means if I add 1 to all my x numbers, that means I have numbers of 1, 2, 5, and 10. And if I add 2 to all my y numbers, I would have 2, 3, 4, and 5. All I have to do to draw that graph correctly is plot those points. So plot a point at 1, 2, 2, 3, 5, 4, and 10, 5. Draw your curve, put your arrow, again, square roots only get arrows on the one side, and you would be done. As we keep going through here, then we get into, again, this time we have the multiplier out front. We've got the multiplier, and we've got a vertical shift, and we have a horizontal shift in here. If you wanted to take a look at what this looks like, our points would be at -4, -3, pardon me, -3, -1, 0, 2, and our other one's going to be off our graph, so that should be enough to get us a good graph there. Okay. We'll do one of the cube root functions just for good measure. Our cube root table, we started with -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. And again, under the radical is our left and right shift, so this is going to be the opposite. We're going to add 4 to all of our x values, and our vertical shift, we are going to add 1 to all of our y values. So if we redraw our new table so that we have our values to plot, add 4 to all your x's. That means I'm at -4, +3, +4, +5, and 13. Yes, that's going to be, 12. Oh, my apologies. We're going to be off the graph here. And then we're going to add 1 to all of our y values, so we'll be at -1, 0, 1, 2, and 3. So this is a cube root graph. This is going to make our snake looking shape. So -4, -1, 3, +3, 0, 4, 1, 5, 2, and 12, 3. So I'm just going to take this out so I can give myself a point out here. Remember, this is going to make our snake-like looking shape with arrows on both ends. Okay. And the same idea should you have a multiplier. The last part that would really be likely to be on our exam, okay, definitely want to keep an eye on a question like 92. I don't know why that keeps happening. Questions like 92 and then something along the lines of 94 here, definitely good 2 options. But again, we'll run through all 4 of these just to make sure. And then we need to talk about the likelihood of the story problem that you're likely to see, and then we should be all done. So let's knock this out. So starting with 92, if we're looking at this problem here, we need to isolate everything that's in the square root. So we are going to divide both sides by 2 at first, which leaves us x plus 1 to the 3/2. 54 divided by 2 is 27. Now I need to get rid of that exponent, so I'm going to flip it and I'm going to raise it to the reciprocal power. Now I need to deal with 27 to the 2/3. Well, 27 to the Slippery hands this late in the evening. 27 to the 2/3. Well, 27 is 3 to the 3rd to the 2/3. Cancel out those 3. That means that 27 to the 2/3 is the same thing as 3 squared, which happens to be 9. The other side is left with just x plus 1. Minus 1 on both sides, we get a final answer of x equals 8. Easy stuff. 93, again, same thing. We're going to solve for that variable. We're going to add 5 to both sides. So we get x to the 4/3 equals 16. We're going to wrap both sides in parentheses, and we're going to raise to the reciprocal power. Well, 16 to the 4/3, we'll just write it over here, or 3/4, sorry. 16 is 2 to the 4th to the 3/4. The 4's will cancel. 2 to the 3rd, well, oh, excuse me. 2 to the 3rd would end up giving us 8, so I would get an answer again of x equals 8. All right, 94, same idea. Isolate the radical. So let's order of operations. We'll undo all of them. Let's get rid of the 5. So then we have 3 times the square root of x plus 6. 14 minus 5 would give us 9. Let's divide it by 3. So we get x plus the square root of x plus 6 equals 3. Only way to get rid of a square root is to square both sides. Well, that'll knock this out and leave us x plus 6 equals 3 squared is 9 minus the 6 on both sides. We get a final answer of x equals 3. Both of those, I think, are likelihood questions that you may run into again. Moving into number 95 here, we have a 5th root, but that's not the worst thing in the world. We're going to get rid of the 3 first. I have the 5th root of x equals 1, but the only way to get rid of a 5th root is to raise it to the 5th power, but that's not the worst thing in the world because 1 to any power is still 1. And 96, nice easy question here. Square roots on both sides, that means we're going to square both of these and get rid of them. That leaves me 2x plus 1 equals x. It gets rid of both of them. So I'm going to subtract 2x on both sides and get 1 equals negative 1x. Divide it by the negative 1 and we get x equals a negative 1. Now, the question that I added, we wanted to put one story problem on here, and because of the project that we finished the semester out with, we decided that we were going to do an interest problem. So we're going to give you the formulas again. Sorry, that was my phone going off. We're going to give you the formulas again. So the question we're looking at is, if you invest $1,000 at a 6% interest rate, how much money do you have after 5 years? Okay, of continuous compounded interest. We're looking at P, the principal, the amount you put in, times E to the RT, okay? This is the formula that we're going to be using for this, okay? Very similar to our standard exponential growth equation. But the thing you really just want to remember is that E is a button in your calculator. So you're just doing 1,000 times E raised to the R, the rate. Well, we said the rate was how much? 6%. So that would be 0.06. And the time, 5 years. This is just a matter, and we're going to pull up our calculator if we can get it up here real quick for this last problem. There we go. Make sure everybody knows where your E button happens to be. See if we can get this loaded up real fast. Nope, we're going to continue with a free trial. There we go. All right, so we had $1,000. Now E, okay, is sitting right over here on the left above the, what's the LN, the natural log button, the chapter we didn't make it to. Oops. Let's take that out of there. So 1,000 times E, and it's going to give you the E, and it's going to put an exponent up there. We said E was to the 0.06 times 5 years. So that's going to give us, if we invest $1,000 and they compound the interest continuously, meaning they're going to give you money on top of money, 5 years from then, if you don't touch that $1,000, you're going to have a total of $1,349.86. Okay, so that's the formula you're going to be using most likely for your story problem. We've covered everything that I think you're going to need to make it through this exam. Again, review these videos as needed, and I wish you all the best of luck.